And now we have some young researchers from Catholic University of Milan. So they will make very short presentation, but I hope good presentation. The first one is Eleonora Martegani. Eleonora Martegani, presentation of Eleonora. Significant decrease of adiponectin plasma levels following 2 different programs of resistance training in healthy and well-trained young adults.
Posso prendere questo? Sì. Thank you very much for the introduction. Good afternoon, and I would like to thank Professor Carraro, who gave me the opportunity to present this work at this Congress. Adiponectin is one of the main cytokines produced by white adipose tissue, and its function is linked to the metabolic homeostasis of our body. This adipokine is involved in lipid and glucose metabolism, in insulin sensitivity and inflammation. For example, it enhances fatty acid oxidation and glucose consumption in skeletal muscle, in the liver and in the heart, and has anti-inflammatory properties in cardiovascular and central nervous system. Adiponectin can be secreted in different forms, namely trimers, hexamers, and high molecular weight oligomers. These larger molecules are essential for exerting its biological function. The regulation of adiponectin synthesis is strictly correlated to the metabolic status of the body and can be influenced by factors such as diet, fasting, inflammation, and also physical exercise. During exercise, adiponectin helps in improving insulin sensitivity and has cytoprotective effects, helping tissue adaptation and repair. In the literature, there are many studies highlighting that aerobic physical exercise can increase circulating levels of adiponectin. However, less is known about resistance training. In general, it's known that chronic resistance exercise can increase the circulating levels of adiponectin. However, its acute response seems to be controversial and strictly dependent on duration, intensity, and metabolic load of each protocol. Thus, the aim of our study was to investigate whether acute resistance exercise can modulate circulating levels of adiponectin, with a particular focus on high molecular weight oligomers. Moreover, we compared 2 different protocols of resistance training characterized by different variables. 9 volunteers participated to our study and performed 3 days of familiarization. Then they performed a first training session characterized by a total of 30 sets of full body exercises, characterized by 70% of individual 1 repetition maximum. The time under tension of this protocol was very high, and exercises were carried out to muscular failure. This protocol was designed to elicit greater metabolic stress, emphasizing the eccentric phase. Then participants performed a second training session, characterized by moderate time under tension and 2 repetitions in reserve. During both training sessions, blood and saliva samples were collected at baseline and after 15 minutes, 24 and 48 hours of rest. Biological samples were then analyzed by ELISA and Western blotting to detect adiponectin, and the creatine kinase levels were assessed by chemiluminescent assay. Participants are healthy young males that are considered resistant trained, meaning that they have a minimum of 2 years of continuous experience in resistance training. Even if their BMI was 24.5, indicating overweight, their body composition was characterized by very low adiposity and elevated muscular mass. In this graph, we can see the changes in adiponectin levels in blood samples following the 2 training sessions. We can see here a significant time-dependent decrease of circulating adiponectin that already begins after 15 minutes and reach 22% of decrease after 48 hours in the first session and 26% of decrease after 48 hours in the second session. This graph represents saliva concentration of adiponectin. Despite saliva is considered a good method to analyze biomarker, including adiponectin, in our case, saliva concentration of adiponectin does not reflect its plasmatic level, probably because adiponectin concentration in saliva is strictly correlated to oral health rather than metabolic processes. Then we analyze the oligomerization status of adiponectin, as we can see from these images of Western blotting. High molecular weight oligomers were the most evident in blood samples, and after densitometric analysis, we can see a significant time-dependent decrease in these larger molecules following both training sessions. To analyze muscle damage, creatine kinase levels were assessed, and we found after both training sessions a peak after 24 hours post-exercise. As expected, the first training session elicited a greater stress due to elevated time under tension and 0 repetition in reserve. The same indication were obtained with the visual analog scale with a peak at 24 hours that is greater after the first training session rather than the second one. To conclude, in this work, we found a significant time-dependent decrease of adiponectin following resistance exercise, regardless of exercise protocol. This suggests that adiponectin regulation may be driven by metabolic stress rather than contraction rate. Our hypothesis is that this decline may represent a temporary redistribution of adiponectin due to its binding to receptors in the tissue that ask high metabolic demand, for example, skeletal muscle and the liver. In this context of resistance exercise, adiponectin could play the role of a regulator of energy balance during the recovery phase after such an acute stimulus. These results have been recently published in Biomolecules as a pilot study. Of course, further analysis should be conducted with a wider number of subjects, increasing the time points, and also by evaluating other biomarkers, for example, to study inflammation. That would help in better clarify the role of adiponectin in the crosstalk between muscle and adipose tissue following resistance exercise. I would like to thank the Laboratory of Cell Biochemistry and Molecular Biology of our university, especially Professor Tavian, the unit of Sports Science of our university with Professor Cereda, and the group of Professor Daniele at the University of Naples. And of course, thank you for your attention.